Okay, are there any questions before we begin? Let me state that I've done some grading and particularly with the labs. Some of you are struggling in the labs, and I want to remind you that you have me to help you work on the labs. I am here to answer questions. So while you're working on the lab, if you do it while I'm here, you can easily answer questions or ask questions, and I'll answer. Some of you, I'm not sure if you're just weak on science or you're just struggling in the lab, but you do need a little bit of help. And if you don't use me, I don't know how you're going to pass the class. So use me. I think I also did the lecture, and most of you did pretty well on the lecture worksheet. All right, any question about any of that? If not, let's oh, there we go. My computer will speed up now. I just finished the it just finished the making the lecture session. It makes it into a video that I can then post. All right, are there any questions before we get started? If not, let's.
Are we, since we haven't really covered chapter 3 in the lecture material yet, we're still covering it, doing that worksheet and all that?
I'm going to be talking about what we're going to do in the lab. Is that what you're asking?
No, I was asking about the lecture worksheet, since we're kind of a little bit behind in that because of that one.
Oh, are you worried because um let me think about this. Probably the lecture worksheet. It's not going to be due when it says it's due because we're behind in the lecture. Is that what your question is?
Yes.
Okay. Yeah, let me go ahead and straighten that right now. Which lecture worksheet is that? Is it lecture 2?
I believe it's lecture 3.
Lecture 3. I don't know if you're seeing my screen or not, but I'm trying to get that now. So it says it's due the 27th. Let me see where we're going to be, because we do have class on Thursday. Let's see, we would finish chapter 2 and start chapter 3, but you certainly wouldn't finish chapter 3. Probably, I'm not going to change it now, but probably the lesson will not be due this. Well, I'll go ahead and change it now. It's not going to be due the 27th. It'll be due a week after that. The thing is that I've got to change all of these, so I haven't gone in and done any of that yet. So that's going to be moved to February 3rd. All right. So you have to remind me if I don't get it done. I've got to do it for the entire lesson. I've only done it for the first lecture worksheet. All right, let's begin with the lab. Let me see where I am. Let's go to the Zoom. Don't think I'm sharing my screen. Yeah, I'm gonna have to change all of those assignments and all of the schedule in the Canvas page, as well as the as well as the syllabus. And this is going to be several hours or maybe even a day of work. That's why I haven't gotten started. I haven't had the time to do that. And even doing the syllabus will be a while. It'll take at least about an hour. So, all right, let's get on to the schedule. We're supposed to be working on Lab 3, Microscope Basics. So let's begin Lab 3.
So on that same note, I was looking at the schedule. I know you said you were gonna update it. It says that lab 4 is also due on the same day. Is that one of the things that is gonna be?
Yeah, the lab schedule will not be changed because we were able to meet for the lab when we were not able to meet for the lecture because the internet was down. So the
Okay.
lab schedule is not going to be changed, but the lecture schedule will be changed, and it's going to be a while before I get it all done because it's really going to take me several days to get everything reprogrammed. But I will begin work on it. I probably won't begin work on it until Friday, but I will try and get started on that.
Okay, so we have worksheet lab 3 and lab 4 due on the 27th.
Let me just take a look at the schedule again. So we have lab 3 on Monday and lab 4 on Wednesday. So yes, on Saturday, lab 3 and lab 4 will be due. The first
Okay.
grading.
All right, thank you.
Lab 3, reread this lab module and the textbook on chapter 3 through the end of the section on compound light microscopy. There's going to be some video clips and online exercises in this lab. You're not going to be physically using a microscope. However, upon completion of this lab module, students should be able to A, locate the name of the parts of the compound light microscope along with describing their functions. B, calculate the total magnification for each objective used. C, know the guidelines for focusing specimens with the different objectives. And there are 4 different objectives you need to know. The scanning objective, which I call the 4X objective, the low power objective, which I call the 10X objective, the high power objective called the 40X objective, and then the oil immersion objective, which is the 100X objective. Realize that when you call them the low power and the high power objective, the low power objective is not the lowest, the scanning is. The high power is not the highest, the oil immersion is the highest. That's why I don't like using these names. You need to be D, able to estimate the size of a specimen when seen at different magnification powers. And E, be able to understand the rules for proper microscope care. And F, be able to define the terms associated with the microscope. All right, any question about these learning objectives? Although you're not going to be using a microscope, we do have a online virtual microscope that you will be using. So the microscopes we have in the lab are called compound light microscopes. You need to memorize the names and the functions of these parts of the microscope. The eyepiece, also called the ocular lens of the microscope, the objective lens, the stage that you put the slide on, the stage clip that holds the slide and then moves it around on the stage. 5, I'm not seeing. Oh, there it is the clip, I forget what you call that, for moving the slide. What do you call that? Mechanical stage control knob, the control knob for moving the slide. 6 is the iris diaphragm. 7 is the condenser. And on some microscopes, they will be in a different order, meaning I think on most of the microscopes in the lab, the iris diaphragm is below the condenser. They are together, and we'll talk about what they each do, but I'm just saying the order can differ. And 8 is the coarse focusing knob. 9, the fine focusing knob. 10, the on and off button for turning on the lamp or the light of the microscope. 11, the rheostat for adjusting how much light is coming through the lamp or the microscope. And the person who made this lab is from Australia, and apparently they don't have the name rheostat in Australia. He calls it the light intensity dial, but I call it the rheostat because that's what we use in America. Any question about any of that? All right. On the rotating nose piece, we have the different objective lenses. They have a name, the scanning lens, which is 4x in power, the low power, which is 10x in power, the high power, which is 40x in power, and the oil immersion lens, which is 100x in power. Now, the objective, or the total magnification of the microscope, is the power of the objective lens times the power of the ocular lens. All of the ocular lenses at Clark College have a 10x magnification in the eyepiece. So that the total magnification for the 4x lens is 40x, for the 10x lens 100x, for the 40x lens is 400x, and the 100x lens or oil immersion lens is 1000x. For the depth of field, that is how much of the object you can see under the objective lens. The depth of field for the 4x lens is deep, meaning if you have an object, you might be able to see both the top and the bottom. I don't know if you can see this. I'm trying to put it in front of my face because it usually shows up in front of my face with the 4x lens. But with the 10x lens, you have a smaller depth of field where maybe you can only see half of the object under the lens. And then with the 40x lens, it'd be less than half of the object. And then with the 100x lens, all you're seeing is a single plane through the object. So you have the narrowest depth of field with the oil immersion lens. Any question about any of that? All right, the field of view is how much of the slide you can see under the eyepiece of the microscope, meaning what is in your field of view. With the 4X lens, you have the largest field of view, seeing more of the slide than any other objective. And as you go up in power, you have a smaller field of view. So the 10X objective will have a smaller field of view. The 40X objective will be a smaller field of view. And then the 100X objective will have only a pinprick, a very small field of view. Comments on the use of these? The 4X lens will be the easiest lens to use because it has the deepest depth of field, and then you see the largest amount of the slide under the microscope. So it'll be the easiest to use. You can see the object more easily with the 4X lens than any other lens. The hardest lens to use is the 100X power lens because it has the smallest depth of field, really just one plane through the object, if you can see that. And then the smallest field of view. So for calculating the total magnification, you simply multiply the magnification of the objective lens times 10x for the ocular lens, assuming the microscope has a 10x ocular lens. There are some microscopes, the most expensive, and I suppose the best microscopes, do have a 20x ocular lens, but Clark College does not have any in the microscope lab, and they might not have any in the entire college, I don't know. When you're seeing an image under the lens of a microscope, not only is the image going to be magnified, but it is also going to be inverted and reversed. So if you're looking at the letter E shown here, it's actually going to look like this under the microscope. Magnified and then inverted and reversed. The iris diaphragm can be opened or closed down, allowing more or less light through the stage. And although this lab does tell you the iris diaphragm is the most important way to adjust the intensity of the light, it's more important that you adjust the iris diaphragm to give the best contrast of the specimen, that's the object you're viewing, against the background of the slide. So the iris diaphragm gives the best contrast. And so you adjust the iris diaphragm to increase the contrast between the specimen and the background of the slide. With the iris diaphragm, when you are using it, you want the iris diaphragm to give a cone of light about equal to the field of view of the objective lens that you're using. So when you first start with the microscope, you should start with the 4X lens, and it will have the largest field of view. Then you should open up the iris diaphragm to about the size of that field of view. So you give a cone of light coming up equal to the size of your field of view. That gives the best contrast, showing the specimen the best against the background of the slide. And then as you go up in power, you're going to have a smaller field of view with the objective lens going up in power. And so you should shut down the iris diaphragm until you come up to the 100X lens, which has a pinprick of a field of view. And so you should shut down the iris diaphragm, the greatest, with the 100x lens, so that you only give a pinprick of a cone of light coming up to the specimen. Any question about that? All right, I've already mentioned when we first use a microscope, you should start with the 4x lens. That's because it's the easiest one to use. You then use the coarse focus adjustment knob to slowly raise the stage to bring the object into coarse focus. You then adjust the coarse focus and then use the fine focus to finally bring the object into fine focus. Now, you should never use the coarse focus because our lenses are parafocal, meaning that once you get it in focus for one lens, it should be in focus for all the other objective lenses. And so from now on, you should never use the coarse focus. You should only use the fine focus. If you make a mistake and you start using the coarse focus, you should just go back to the 4x lens and use the coarse focus to get it in good focus, and then go to the fine focus, and then go to the other objective lenses, the other objective magnifications, and only use fine focus from here on. So you only use the coarse focusing knob with the 4x objective lens in place. All other additional focusing should be done with the fine focus knob. Let me explain what parafocal vision is. It has the different objective lenses in place so that when you have one focusing in on the specimen, all other objective lenses will focus in on that specimen. Parafocal vision, it's called. When you are moving from one lens to the next higher lens, you should always move your specimen into the field of view. You should, sorry, not into the field of view. You should always move the specimen into the center of your field of view. For example, let's say we're using the 4x lens and the specimen you're viewing, this is the field of view you're viewing under the microscope. The specimen you're seeing is over here. You should move that specimen into the center of your field of view. The reason being is that when you go up to the next higher objective lens, its field of view will be smaller, and so you will not see, let's make it like that, you will not see the specimen in your field of view unless you move the specimen into the center of your field of view. And then you fine focus to get the specimen in fine focus, observe it, and then move it once again to the center of your field of view before you move up to the next higher objective lens. Once you come to the oil immersion lens, you'll need to add a drop of oil to see the specimen under the oil immersion lens. And it is true, you can use the 100x lens without using oil, but it doesn't magnify any better than the 40x lens. And since the 40x lens is easier to use, you shouldn't use the 100x lens unless you're using oil. Oil is something that needs to be put into place specifically. And how you do that is you move the 40x lens halfway out, but you do not move the 100x lens all the way into position. You have it halfway out also. And then that halfway out will allow you to bring in your container of oil and put in a eyedropper of oil, put in the drop of oil over the specimen. And then you move the 100x lens into that drop of oil. And that's how you use the 100x lens and put in the drop of oil. Oil has the same refractive index as glass, which allows more light to be gathered by the lens than without using oil. This greatly increases the resolution and clarity of the image. And we'll talk a little bit more about that later in the lab. I think it's in another lab, but it might be later in this lab. I think it's in another lab though. All right, if you've used oil on your microscope, you'll then need to clean the oil off of the microscope. Always clean the 100x objective, and you should also check the 40x objective, because if you're moving the ocular lenses, I don't know if you can see this. Like I said, the drop of oil will be touching the 100x lens, but if you move the objective lenses around, that 40x lens will also touch the drop of oil and can pick up oil. So you should check the 40x lens to see if it has oil on it. And if it does, remove it, clean it from that lens as well. To clean the lens, you only use lens paper. And for you guys, that's really all you use to clean the lenses. If you need the lens cleaner, it's a liquid cleaner with probably something like ethane or acetone. Usually students would call me over to clean the lens, and I would clean it for you. All right, any question about using the microscope? So online students will not perform any of the activities in this lab, but you will be not using a real microscope, but you will be using a virtual microscope, and you will be expected to know the information contained in the table and how the formula for 0.5 below works to measuring the size of a specimen you're viewing under the microscope. So when you're using the 4x lens, the diameter of the field of view is 4.5 millimeters or 4,500 micrometers. The 10x lens, magnifying lens, the diameter of the field of view is 1.8 millimeters or 1,800 micrometers. The 40x lens, objective lens, the diameter of the field of view is 0.45 millimeters or 450 micrometers. For the 100x lens, the diameter of the field of view is 0.18 millimeters or 180 micrometers. We gave you this information because you can't measure it under the microscope, but if you had gone into a real microscope lab, you would actually measure these yourself. It's important to know the size of your field of view so that you can use that to estimate the size of the specimen you're observing. For example, if the specimen you're observing under let's make it the 10x objective, if the specimen takes up half of the field of view, then what is the size of the specimen? Can anyone tell me that? All right. If the specimen were to take up 100% of the field of view, then the specimen would be 1.8 millimeters across. Since the specimen takes up half of the field of view, then that would be half of that, or 0.9 millimeters across. And you will be expected to know how to make those calculations using this table, and obviously whatever objective lens you're using, to estimate the size of the specimen. You'll need to do that for this lab as well as the quizzes. For activity 2, you're going to be observing prepared slides. You won't be doing this in reality, but you will be doing a virtual exercise of this activity. And you can find the virtual link near the end of this document. And we expect you to understand the material in this exercise. So this is the activity that you're going to be using. For activity 3, it's making a wet mount. Online students are not going to perform this activity, and you will not test it on this procedure, but you should read through it if you've never made a wet mount, because you should know how to make a wet mount if you've taken microbiology. Any question about activity 3? All right. We do not have a virtual lab on the wet mount. For microscope storage protocol, online students will not be handling a real microscope. The closest you'll have is a virtual microscope, but you are expected to know how to correctly store and clean a microscope. After using a microscope, these steps must be performed before putting the microscope away. First, you lower the stage completely on the microscope. You remove the slide and you put the slide away. If you used oil immersion, then you must wipe the oil off using lens paper. You never use chem wipe, other paper like a paper towel or any paper. The reason is paper, shown here, has wood fibers in it, and those wood fibers will scratch the lens. The lenses are the most expensive part of the microscope, and once they're scratched, you would have to use that microscope for the rest of the term, dealing with it. And all future students would have to deal with it too, because we're not going to be replacing the lenses all that often. What you use is only lens paper to clean the lenses. Lens paper is paper, but it has had the wood fibers removed. So lens paper will not scratch the lenses. You then put the 4x objective into place. That means bring it to over where the specimen was. You lower the intensity of the light to minimum. You switch the power of the light off, unplug the microscope from the electrical outlet, and wrap the cord neatly around the microscope. You don't do number 7, but you use both hands to hold the microscope to carry it. you have one hand on the arm or the neck of the microscope, and then one hand underneath the base of the microscope, keeping the microscope in upright position. You then place the microscope back in the same cupboard you got it from, and in the same way you put it. This isn't stated here, but the way we have the microscopes in the lab, maybe I can do it this way, as this would be the back of the microscope, so the eyepieces will be back this way. You put the microscope in the cubby hole this way. Is that clear? Maybe if I do it with this one, it'll be a little clearer. So this will be the microscope where the ocular lens faces you. You put the microscope in that way. All right. Excuse me, know the terms of a microscope? You can skip the references, and then let's do the laboratory exercises. You can view the following video clips on using a microscope. This one shows you general microscope focusing. This clip shows you how to add oil to the microscope. And then practice your microscope skills using a virtual microscope. Click this link, and it may take time to load. Not too bad on my network, but depending on how fast your network is, it may take time to load. All right, there's the virtual microscope. And then these are the things you can click on. We're going to click on Explore. And this is the slide box. So you open it by clicking the question mark. And I suggest you look at the plant slides, the onion root slide, load it in. And this is what it looks like under the 4X lens. You then need to use coarse focus to bring it in coarse focus. And someplace around here. Then use fine focus to get it in real crystal clear. You can adjust the light with this one. Probably around there someplace. And it's already in the center of your field of view. You can't move it in the center of your field of view. But then switch to the 10X objective lens. You notice how that changed? And you'll notice that it's in parafocal vision. So you should only use fine focus to get it in fine focus. And boy, that doesn't look like it. Oh, there it is. Maybe around there. Now, someplace I have a chromosomes. I'm not sure where it is with this power. Let's go up to the 40X lens. Oh, there it is there. The one with chromosomes. And then fine focus to get it in good power. And then using the 100X lens, you have to put it halfway out, halfway in, leave it at that position, and then get your oil, which is over here, and it tells you what to do. Add immersion oil, and then add the immersion oil. How you do that is you click on the question mark, and that adds a drop of oil, and then we need the fine focus. And it looks like we can't get better than that. Let's adjust the light, increase the light a little. Let's see if I got the chromosomes. Not exactly. I don't think I can get the, oh, there they are there, the chromosomes there. All right, any question on using the microscope? This is a little bit out of, let me see if I can shrink this. There we go. Now let's go ahead and remove the slide. And now you need to use the lens paper to clean the microscope. You don't use chem wipes, for example. Tells you not to use it. And then you go there and it actually cleans the lens for you and then puts the slide in there. All right, any question about that? Let me see. How do I go back? That only gives me more of those. Looks like to get this done, to go back and come to the guide again, I gotta reload the page probably. So there's the guide on what to do, what the learning objective is, which is actually not what you need to do. Explore is what we will use. And then if you want to test yourself, you can go through the different test questions. Care and usage of the microscope, calculating magnification, and then help in learning the terminology. Let's see if I can get out of here. Nope. There was one more link I wanted to look at. I don't remember what it was. Options. Oh, just controlling the virtual microscope. All right, any questions about the virtual microscope? If not, let's go back to our lab module. Come on. Close that down. Oh, here it is. I don't think I need that, so I'll close that down too. I think I've closed down the module by mistake. All right, we're actually on the worksheet, so I guess I can close that down. So the links for focusing the microscope, the links for adding oil to the microscope, the virtual microscope link, and then this one will be practicing naming the microscope parts. Let me see if I can open that. There, I got it. It's kind of a game. Press play to start. And there's the play button here. What this does is it does have a timer, but it tells you the name that it wants you to identify. And so you find the arm of the microscope and then click on it. Here's the arm of the microscope. If you get the correct answer, it'll be green. If you get an incorrect answer, well, I've already got the correct answer, so let's go on. Resolving nose piece, let's go to the wrong answer. I thought it gave you a red. All right, it doesn't. And then it highlights, there's the resolving nose piece. And we go there and apparently that one I marked wrong because I got 3 wrong guesses. The lower objective lens. It's kind of hard to see, but I think that's the smallest one. I'll go there. If it's correct, it's green. And let's go to the next one, the high power objective. Let's go there. Yep, I got the right answer. I was thinking that was the high power objective. That must be the low power objective. Fine adjustment knob. Let's go the wrong answer again. So that's the first one. You know, I thought it gave you a yellow or a red if you got the wrong one, but there's the fine adjustment knob. Oh, so it's yellow if you didn't get it right the first time, but it's right the second time. And the diaphragm, the iris diaphragm is there. Let's go wrong, wrong. Now there. So it's a darker yellow if you miss two. And then if you miss all three, it'll be a red. Medium power objective. It's the low power. If that's the high power oil immersion, that has to be the medium. Ah, there we go. That's green. I was confused because it had color to it. And anyways, that's how you use this. It'll help you identify the different parts of a microscope. And then fill in the blanks with the correct answer. When focusing a specimen, you should always start with which objective lens. When using the low power, high power, and oil objectives, only which focusing knob should be used. 4C, the type of microscope used in the lab is this and that, and that's a double name microscope. Don't give me the type of microscope like Nikon microscope. Some of our microscopes are Nikon. I don't think all of them are. So tell me what type of a microscope it is. And then the rest of them, answer the questions. Let me state that one that students frequently get wrong is how large is the field of view when using a high power objective lens? You need to give an answer in millimeters or micrometers. You cannot say simply small, large, whatever. You have to give me an answer in millimeters. And then two, suppose a typical bacterial cell is 2 micrometers in diameter. In the circle below, which represents the field of view of the microscope, when viewed with the oil immersion objective lens, state how many cells can fit across the circle under our oil immersion lens. For full credit, show your calculations in your answer. Any question about any of this? All right, I'm here to help you. I'll be here until about 8 o'clock or until the last student logs out. Any questions? If not, go ahead and get started on the lab. Yes, which quiz are we talking about?
The one that we have on Wednesday or due by Wednesday. Are you able to give us any kind of like direction or what that looks like?
It'll look like the previous quizzes that hopefully you've taken. As to what's on the quiz, I think that's what you're asking.
I guess both, maybe kind of what.
You can take a look at the syllabus and it lists what will be on the quizzes.
Okay, thank you.
As soon as this opens, boy, my computer is really slow.
Will it be just
Just give me a minute, it'll come
multiple
up. Oh, here it is. What?
Oh, I was wondering if it'll be just multiple choice or like the essay questions.
Yeah, it'll be multiple choice. So 123 will be quiz 1. It'll cover chapter 1 and 10, the start of chapter 2, what we covered today, and then labs 0, 1, and 2. So the quiz questions will cover that material. And yeah, they'll all be multiple choice.
Thank you.
All right.